this is Britt Caswell with another example video. In this video, I'm covering example 6 from section 5-4 in the SavvasRealize Algebra 1 textbook. So the goal of this example is to understand transformations of the absolute value function. So we are taking all of the transformations that we have learned so far and putting them in one single spot. So I just want to give you guys a couple of reminders. Anything that happens outside the grouping symbol, like you see with the A and the K here, are going to be vertical changes. Okay, that means that it's going to affect the y-axis. Anything inside the grouping symbol is going to be a horizontal change. So with our A value, which is the number multiplying to the grouping symbol, if you have a negative A, you're going to have a reflection. If the value for A is bigger than 1, you're going to stretch the graph. And if the value for A is less than 1, you're going to compress it. Now, in terms of adding and subtracting from the function, these are all going to form translations. So if you add or subtract inside the grouping symbol, you're going to translate either to the left or the right. So if it says x minus h, you're going to go to the right, and x plus h, you're going to go to the left. And remember, that feels backwards, right, because of the minus sign that's in the equation. And then with the vertical translations, we're looking at the k value, which is outside that grouping symbol. So if you add k, you're going to go up, and if you subtract k, you're going to go down. So what we're going to do is we're going to look at a graph of a function. I'm going to make it slightly larger for those of you guys watching the video. And we're going to identify our a, h, and k values. And once I know those values, then I'm going to create my formula. So the first thing I'm going to do is I'm going to look for my a value. And that's just going to be the slope of this right-hand line here. So my slope, right? Okay, my slope is rise over run. So this is rising by 3 and running by 1. Alright, so my a value is going to be 3 over 1, which is 3. So then my h and k values come from this vertex. So my vertex is at 4, 1. And so that's my h and my k. So if I go to create my function, I'm going to leave space for room for the a. And then I have an x minus, and then I'll have a plus k on here. Alright, so my a value, again, the slope of that right-hand side, was 3. So this one was stretched out, right? It's not quite as wide as our normal absolute value equation. My h was a 4. Now remember, when we plug this in the equation, it's going to look like we flip signs because there's already a minus there. So that's why it says x minus 4 instead of saying x plus 4. And then my k value is a 1, so I'm going to put a plus 1 on the outside here. So there's our function. Alright, so they have us doing it for a couple more graphs just to practice. So let's go ahead and let's check this one out. So again, my a value is the slope of my right-hand side. So I'm just looking for this slope right here. So it looks like we rise by 3 and we run by 2. So the m, which is our a value, is 3 over 2. So if I start writing out my function, right, I have f of x equals, alright, and that a value goes right here. Now the vertex of this function is at the ordered pair -1, 2. So that -1 is my h value. And so there's already a minus here. So when I subtract a -1, this is going to turn into an adding of 1. So that's why my equation says plus 1 here, because you have to flip that sign. And then my k of 2, I'm going to put a plus 2 out here. So there's the equation for that graph. Now on this one, they describe it in terms of the transformations. Alright, so if we're translating, that's going to be a change to our vertex. So it says 1 unit to the right and 4 units up. And there isn't any stretch or compression, right? So this graph is going to be a V. Come on, little buddy. Oops. I was hitting control and I messed up my graph. Give me one moment, please. There we go. Gotta hit shift for my straight line. So I have my vertex, and so this absolute value function is going to continue to go up with a slope of 1 and negative 1, which looks kind of like that. Sorry that it kind of falls off my graph a little. So our A value here, because there was no stretch or compression, our A value is 1. And that's okay. That just means that we won't have a number in front of the absolute value, right? Because normally we would put a number here where A is, but since A is 1, we're going to just have an imaginary A. So then I have x minus a number, so I have it minus h, which is 1, and then I add that k at the end. So here is our formula. So there we have it. That is understanding transformations of the absolute value function. Until next time.